Free body diagrams. Free body diagrams are used in physics whenever we talk about forces. Free body diagrams are often necessary to solve problems that involve forces. In physics, we use free body diagrams to show all the forces acting on an object. A free body diagram is a sketch of the object that only shows the forces that are acting on it. To make a free body diagram, start with step 1. Identify the object that you are interested in. Draw the object as a block or a circle. Make sure that your object is large enough that you can add all of the forces. Step 2. Identify the surface the object is on, if there is one. Draw a line to represent the surface. Step 3. Identify the forces that are acting on the object. Look at the table above for possible forces. When drawing the forces, the force should touch the object. Step 4. If the object is moving, add a V or an A with an arrow to indicate the direction. These are not forces, so they should not touch the object. Step 5. If there are several objects, use the same symbol for the forces that have the same magnitude. Step 6. Discard other objects that are acting on the object of interest and replace them with the forces they exert on the object of interest. Let's look at some examples of free body diagrams. An object is falling. Air resistance is negligible. So the first thing is we're going to draw a box to represent the object. Then we know that we have gravity, so that's an arrow down. And our arrow, our force, starts from the center of the box. That's the center of mass. Since air resistance is negligible, that's the only thing that we need to put on that diagram. An object is sitting still on a level surface. So since we know it's sitting still, we still have gravity going down, but it's not moving, so there has to be another force. So that would be normal, and normal is always perpendicular to the surface. So since the surface is level, it goes straight up. An object is sitting still on an incline. So we draw the incline and our object. Gravity always goes straight down. So that's the first force that we'll draw. Then we have normal, since it's sitting still, and normal is always perpendicular to the surface. Now the object isn't moving, so that means that there's one more force, and that would be friction. So our force of static friction is going opposite the direction it should be moving. So it should slide down the hill, so friction goes uphill, parallel to the surface. An object is suspended from the ceiling. So we draw our object. The first force is gravity, going down. But since it's not falling, there's another force, which is going up, and that's tension. And so since the object isn't falling, those two forces are equal in magnitude. An object stretches a spring to the right while sitting on a surface. We know the object is sitting on a surface, so that means that we have gravity going down. Since it's on a surface, we have the force of normal going up, perpendicular to the surface. And we have the force of the spring. So the spring is stretched to the right, so that means our force of spring, or spring force, is moving towards the right. A force is applied to an object that is accelerating right. So we have gravity going down and normal going up. The object is moving to the right, so we have an applied force that goes to the right. Now that would be it if we ignore friction. If we have friction, then it would go in the opposite direction of the motion. And so we would draw an arrow to the left, but it's much smaller than the force that's applied. Because the object is accelerating. An object is slowing down while sliding to the right. So we draw the object. It's on a surface, so gravity is going down, and we have the force normal going up and perpendicular to the surface. The object is slowing down while it's moving to the right. So if it's slowing down, that means it's slowing down because of friction. And so there's a force of friction, kinetic friction, that goes to the left, opposite the motion. An object is accelerating down an incline. So we draw the incline and the object. Gravity is always going straight down. And we have the force of normal that is perpendicular to the surface. So if this is just sliding down an incline, those are the only forces that you'd have.